Entonces, in 45, we have 512 x cubic plus 125 t cubed. I explained last class that this is a classical, bueno, it's different of square or sum of cubic, cubic. Sum of cube is a cubic, the formula, plus b cubic is equal a plus b, a square minus ab plus b squared. This is the formula for the sum of cube. Let me copy just in case the differences that we used in last time. It's similar, very similar, except, of course, this is minus, no? Because it's different, and this is always plus. In this case, is plus, is minus in the trinomial part. So, student, try to condense in this formula in two, using this idea. Look, a cubic plus or minus, using this symbol b cubic, is equal a plus or minus is the same sign. Es parenthesis, plus or minus b, a squared minus plus, completely opposite, ab, b squared. It's similar, either way. Or you memorize, no, because you have in the notebook in the test. Okay, the new thing I try to explain is, even by explaining, in this case, you put arrow, and this arrow means cubic root. So I need to find cubic root of 512 x cubic. Well, I know the variable is easy, it's just s, because 3 divided by 3 is 1. But a cubic root 512, we can use a calculator, of course. So now, look, I try to do in my calculator, because it's exactly the same calculator I show you now in the picture. I have now in my hand. Now, you, for example, you press a cubic root. So you press something like that. This is the display. I try to represent display. You represent, for example, 3, you press 3. Why? Because it's cubic root. Look, this 3 in the display. And you press second, daqui, let me use another color to see much better. You press second, and you press daqui, que es la que greater than, but actually, okay, no problem, David. And you press this key, and automatically I see in the display something like that. X squared, the radical symbol. Okay, that's mean in the paper language, cubic root. Entonces, mandatory, you put a parenthesis, you open the parenthesis, and you put the number, que es 512. Close the parenthesis, 512. Close the parenthesis, press enter, enter, and you get 8. And the next time. Okay, entonces cubic root is AS. 125, we can do exactly the same, but I know my memory get 5. Like cubic root 125 t cubic FIT. Entonces this work in our problem like A and B in the formula. What formula? That formula. Like the sum of cube. And you open, wow, you open one parenthesis, O sea, continuation this. We open one parenthesis que represent the first one. And inside the parenthesis, you put A and B, pero who is A and who is B? And our problem is AS plus 5T. And the trinomial part. Trinomial part is, you know, the formula say que is the first square. And the first case AS squared is 64 x squared. Minus, be careful, minus multiplication both AS times 5T is 40. 40 ST. Doesn't matter. Plus square the second, que B squared is 25 T squared. Okay, and it's the final answer. Everyone saw the organization of this. You understand very well the organization of this or no? Answer me. Answer me. Yes, no. Good, no.
I understand.
Super. Entonces, Yasmin and company. What option you consider is the correct? And 45. We are doing 45, no? 45, 45, 45, 45, 45. Let me make it soon. 45, 45, 45, 45. Es obvio que es B, ¿no? ¿O no? Remember que I make it
B.
B, you are right. It's B. Any question, guys? Is typical sum of cubic problem. Sum of cubic. Okay. Everyone follow me? Let me see the attendance now. Angelica. Okay, follow me. Davey.
Yes, I'm here. I follow you. I have my calculator.
Good. Kevin. Alejandro. Samuel. Campos. Kendry.
Yeah, here.
Okay. Dalida. Sherman. No, I saw Sherman. Y los Juan. Both Juan. Okay. Let's continue. One more similar to the 45, 46. Okay, let me delete the calculator. I don't need the calculator, I suppose you know. Okay, now let me erase that part. Okay, no, using the pen. Okay, good. The formula stay. I want to keep the formula. Okay. 46. Well, 46 is similar. Okay, but the only new is that we have, when we have 512 C cubed plus 343. I did before, okay, the cubic root 512 C cubed is AC. And I consider this like my A, the formula. And cubic root 343, I have no idea. I put in my calculator just in case. Is remember. Putting on the calculator on is clear. 3. Second, the key I showed you before. And 343. 343, close the parentheses. Press enter. 7 is 7. Okay, it's 7. Okay, no variable, it's just number. And the formula say A plus B. A plus B is AC plus 7. In the trinomial part, square the first, 64C squared. minus multiplication both 56C plus 49. Welcome from 49, 7 squared. I suppose que the option D, no? It's okay or no? No, hello. No D, es C, no? No, A. Is correct? Help me, guy.
Yes, that's correct.
Okay. Well. So let's move on to another topic. Very important, very interesting, very useful, que is application of the factorization. So I suppose in this moment we cover any possibility of the factorization. Okay, let me try to spend time, why not, now, to summarize everything. Okay, strategy for the factorization. For factorization. Okay, important, because I summarize the big idea. Okay, the first thing you should do, step one is determine GCF, always. Some people forgot that part and try to go direct to trinomial, binomial. Not good. Because you are working with the horrible trinomial. No, GCF simplify the thing. And you factor out. So what are the actions you should do? Factor out. Factor out what? Factor out the GCF. Put out. Entonces now, in the new expression that we have inside the parenthesis, I suppose que es relatively easy than the original. And you manipulate using another technique. Okay, and step two is we have three possibilities, no? Possibility number one is factor by grouping. And how do you know que es grouping? Well, because the clue is 4 terms. You see 1, 2, 3, 4 terms. Oh, grouping. I try. Possibility number two, trinomial. How do you know que es trinomial? Oh, 3 terms. Okay, but no, trinomial is not too easy because we have 3 kinds of trinomial: regular is the trinomial when the leading coefficient is 1. Suppose this is a regular. How you identify a regular? Because this number is 1. Si this number is not 1, es especial. Suppose 3x squared minus 4x plus 1. I don't know. I don't want to solve it. I don't want to indicate. When this number is not 1, it's special. And you know that you multiply like that, I don't want to repeat this idea. And the perfect square. Perfect square, que es trinomial, que es the case que the student never remember. But it's very, very useful. Entonces es, suppose this x squared minus 4x plus 4. Entonces son estudios dicen, no, it's not, I don't memorize perfect square. I memorize regular. Entonces I solve it by regular. Yes, you can. Of course you can. But in some special case is very, very, very useful using perfect square. And finally, possibility number 3, binomial. How do you know que es binomial? Two terms. And how many cases we have inside the binomial? When we have the famous difference of a square, a squared minus b squared equal a plus b. A minus b is the formula that we are using in our specific example. A difference of qb. I want to copy again. A minus B, A squared plus AB plus B squared, and a sum of cubic, que es A plus B, A squared minus AB plus B squared. I want to remember that the sum of square is impossible factorization. Let's call it prime, and also prime this trinomial and this trinomial. Don't waste the time to do this factorization because it's impossible. That's the reason that the formula you write like a trinomial. See, it's possible to say you break it down into no, break it down. Don't try to do because it's impossible. Okay? And this is the strategy, guys, big picture. You see it first, and you count. How many terms we have in our expression? 4, 3, or 2? 4 is grouping, 3 is trinomial. Okay, this is the most complicated because we have 3 kinds of trinomial, and 2 is, well, it's also a little bit complicated because you have several possibilities. We have different of square, different of cubic, sum of cubic. Okay, any question? This is the strategy for the factorization. Okay, some people, for example, don't remember GCF first. This is extremely important in my opinion. Okay, let's move on to the application now. Application. What is the reason that we are using factorization in algebra? Well, there are several reasons, not only one. And we study today, right now, one application. And one application is in the solution of the quadratic, in general, polynomial equation, no? But in this case, specifically quadratic equation. Look. Okay, look at that. Let's move on to 47 problem. And 47 problem, I want to copy again. We have 47 m squared minus 49 equal to 0. Okay, this is quadratic equation. It's completely different to the equation that we are solving before, que es linear equation. Linear equation is, 3n plus 2 equals 5. Because the degree of this equation is 1. Degree 1, linear. Entonces, degree 1 means that we have one solution. Well, sometimes we have no solution or infinity many solutions, but on the 99% of the case, we have only one solution. However, in the quadratic equation, we have 2 solutions because it's exactly the same. 2 solutions. It's exactly the same of this exponent. When the exponent is 2, 2 solutions. Of course, it's in general polynomial. See, polynomial, the degree is 3 solutions. Polynomial, let me explain that the exponent must be mandatory a whole number. So a typical exponent of the polynomial is 0, 1, 2, 3, and so on. Bam, bam, bam. It's a whole number. No fraction, no decimal. Whole number. Okay, but specifically, we are solving quadratic. Quadratic when it's degree 2. Important. In our subject, this case, degree 2. And we have always 2 solutions. Okay, so what is the organization that we are doing? In our equation, in any equation, we have the left-hand side and we have the right-hand side. Because, look, the important thing que characterize the equation is the equal sign. So when you write this m squared minus 49, this is no equation. This is expression, algebraic expression. When you put equal sign, entonces this become equation. Entonces now the important thing in one equation is split left and right is the equal sign. Now, to solve this, you try to express it, the equation in standard. what means to be standard? Standard is when the right hand side is 0 is equal to 0. Nice. In this case, nice. And the left hand side, you organize in descending order of the degree. So this is n squared degree 2. 49 degree 0, because I suppose you have m to the 0 power. Okay? And n to the 1 is missing. So in general, the quadratic equation is like that: ax squared plus bx plus c equal to 0. We have the complete collection of the coefficients. A is the coefficient and the degree 2 square, quadratic. B is the coefficient and the linear. And C is the coefficient when the x is 0. That's the reason any variable or any number raised to the 0 power is equal to 1. Entonces es just C. Okay, this is standard. And for solving the equation, always we put in a standard. You manipulate. Sometimes it's already given a standard. Nice. I appreciate so much. However, no, sometimes no. Okay. So we come back again to the our 47 example. In 47 example, I want to recap again. It's n squared minus 49 equal to 0. I know it's quadratic equation number 1. Number 2, I know that we expect two solutions. Number 2, I know that it's already expressed in standard number 3. Now you take the left-hand side, and we focus in our expression. You ignore temporary the right-hand side, and you determine, wow, it's a binomial. It's a binomial, so I apply factorization. I realize also that it's different of a square. And the square root, this guy is n, and the square root 49 is 7, plus or minus. And this is a super important moment. And you apply one thing, is called zero factor property. Zero factor property. And what is that? Well, it's easy. You take each factor, que es n plus 7, and you suppose que es 0, or n minus 7 equal to 0. Okay, entonces this factor is 0 when n plus 7 is 0, n minus 7 is 0, or both. That's the reason that we're connecting by OR. You solve them separately, both parts, and negative 7, and a positive 7. Okay, so now our solution is solution for the example negative 7, comma, you separate by comma 7. Okay, or not necessarily this curly bracket, you separate by comma, listing by comma. Es obvio que es the option B, negative 7 and positive 7. Do you see? Do you see? Okay, 48 now. Well, it's exactly the same. Well, not exactly the same, but the same strategy. Look. Look, 48. 48 is 48. X squared plus ax minus 20 equal to 0. Again, the same kind of question. Is quadratic equation, degree 2. Two solutions we expect. Is expressed in standard. Nice. Now we focusing in this expression and perform factorization. It's obvious that this is trinomial. A trinomial, and what kind? Regular trinomial, no? Oh, this is easy. I put XX, I try to find the combination that open the door. Two numbers can multiply, give me 20. And somehow when you put together addition or subtraction, give me 8, no? It's supposed to be 10 and 2, no? 10 times 2 is 20. And somehow 10 minus 2 is 8. Here's the only possibility. We have no more. Because remember the shortcut is 20. 20 is 20 times 1. Okay, 10 times 2 is 4 times 5. However, this is 21, 19, this is 12, this is 8. Got it. It's the combination. This is 9 and this is 1. No good. This is our combination. So what sign? Remember the agreement of the sign. This sign is negative, indicate us, it's different sign. And this is positive is assigned directly to the bigger, greater number. Positive and negative. And you separate. X plus 10 equals 0. That means x equals 0, sorry. Equals 0, that means our solution is negative. And x minus 2 equal to 0 is directly positive. And one shortcut, like is, the solution, the signs of the solution always is opposite to the factorization. And the factorization you see positive 10, and the solution you see negative 10. And the factorization you see negative 2, and the solution you see positive 2. It's obvious, right? And the answer is obviously A. Negative 10 and positive. Any question, guy? No? Easy, eh? Well, let's practice. Solutions are basically the thing we are doing today. We are doing more, but today is using the factorization for solving quadratic equation. Okay. Practice this. Yeah. What page? The page. Oh yes, the page. Okay. Let's using our imagination, guys. Suppose. David, you see the page or no? Yeah, David.
Thank you. I see it, Professor. Thank you.
Okay. Let's do it 49. 49 say. 49 say. 5x squared minus 30x plus 40 equal to 0. It's a quadratic equation, good. It's already expressed in standard form, super good. Okay, however, I want to explain one or some important details. For example, I can see in this equation before to start, I see the coefficient is 5, 30, or negative 30, doesn't matter this sign, and 40. And that number is multiple of 5. So you can perfectly, always perfect, legal, divided by 5, our equation. Of course, when you divide by 5, the number decreasing, no? And it's easier, my equation. No? So now is x squared, because 5 divided by 5 is 1, minus 6x plus 8. Wow, fantastic. And this equation is super easy because now we convert magically this horrible trinomial in a regular trinomial. The factorization is pretty easy. Is xx, and the combination is supposed to be 4 and 2, no? Because 4 times 2 is 8, 4 plus 2 is 6, negative. Both signs, this sign positive indicates same sign, negative 8. So therefore, x equals 4, and x equals 2 is the solution. X equals 4 and 2, 4 and 2, 2 and 4, it doesn't matter the order, positive both. It's the option B. Any question? So this is perfect legal. It's a technique I explain now. in order to when you discover the greater common factor, when you discover the greater common factor between 5, 30, and 40 is 5. How you discover? Well, you can use intuition or not necessarily intuition. You copy 5, 30, and 40. And you break it down. 5 is impossible because 5 is prime number. 30, no. 30 is divisible by 2, que es 15, es 35. And 40 divisible by 2 is 20, and 20 is 2 and 10, and 2 and 5. I can discover que 5 is our common factor. And also is the greater common factor because we have no more. Okay, so you, in this moment, you say, wow, I divided by 5 the entire equation. You divide by 5 and you get super easy equation. Let's move on to the example 50, que look like horrible, a little bit complicated. 50. Okay, 50 look like horrible. 15y squared, 50. 15y squared plus 22y plus 8 equal to 0. First of all, classification. What do you think? The expression on the left-hand side is trinomial. What kind of trinomial? I have no idea. ¿Es regular? Pues well, es regular. However, when you multiply 15, wow, entonces it's not regular, it's special, because the coefficient here is 15. When you multiply 15 and 8, 15 and 8 is 120. Not good to apply factorization by grouping. I explained that when you multiply that number and the answer is greater than 100, so my recommendation is don't do it this way. Do it by try and error. Okay, I know that you don't like, but it's the best option because it's like guessing. You take the first guy and break it down. The possibility is 15y and 1y. Another possibility is 5y and 3y. No more possibility. This or this together form this guy. This guy is more complicated because we have a and 1, we have 2 and 4. And that's it, not too more complicated than 2 and 4. Now, this is the moment to select what combination is the correct. Well, I try always. Remember, it's a try and error. But I try to select the easier number, so the smaller number, no, because maybe it's good. This and this. I want to select this. And remember, you copy in 2 different possibilities. You copy 4 parentheses, like that. And you copy 5y, 3y, 5y, again, exactly the same, 3y. But 4 and 2, you copy like that. You copy, for example, 4, 2, and 2, 4. Now you reverse this. This is reverse. This stays the same in both. Now what about this sign? Well, this sign is so big. It's so big as positive. Because every sign in the original trinomial is positive. There are no reason to change the sign. They put plus, 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 plus. Now we are doing a special product in which you are doing no FOIL. You are doing only outer inner. So multiplication outer, inner, inner. Sorry, inner. inner, outer, inner. When you multiply, you have 10y, and you have 12y. Yeah, I need, in the original problem, I need 22. Oh, could be this, because when you add in this guy is 22. Oh, this is 20. Look, 5 times 4 is 20, and this is 6. Now, this is not good. When you adding is 26, when you subtracting is 14. No. This is good. Why? Because it's 22. Just in case, I get the combination. However, I need to verify that everything is okay. How are you checking that? Well, 5y plus 4 times 3y plus 2, you FOIL, pero completely FOIL to verification. This is 15 y squared. This is 10. I did before. This is 12. And this is 8. And when you combine this and this, I did before, it's 20. Okay. Well, this is expression, but we come back to the equation. I discovered that this equation is equivalent to say 5y plus 4 times 3y plus 2 equals 0. Now it's equation. The only thing I did was factorization the left-hand side. This left-hand side, I did the factorization. Now I separate like a two linear equation. And it's super easy. Solve for y in both linear equations and in the story. I move forward to the right hand side like a negative, 5y equal negative 4 divided by 5. Y is equal, continuation here, negative 4/5. This is my one solution. My second solution is 3y equal minus 2 divided by 3. Y is equal negative 2/3. Okay, I have the solution. It's a fraction, both negative. Okay, let me check it out. What option we have? In the 50 problem, it was negative 4/5 and negative 2/3. Es obvio que es de option C. It's obvio que es de option C. Any question? Okay, guys, this is not too fast. This is a slow down. Take your time to processing the information. Okay, this is a typical example, try and error. Try and error, I try to avoid when it's possible by grouping, but sometimes it's the only option that we have. Okay, let's do it. 51 now. Okay, 51. Let me copy 51. Oof, 51. No, look like easy. Okay, 51 is 6k squared minus 17k minus 3. Okay, classification again. This is trinomial. This expression is trinomial. What kind? Special, because the coefficient is in front. The quadratic is 6, no 1. Entonces I need two multiplication, this and this. It's 18. I don't care, the sign is not important in this moment. Entonces the combination to get 17, I suppose que es only 18 and 1. 18 and 1 together, multiplication is 18. And somehow 18 minus 1 is 17. I suppose que this is the key, open the door. So remember, you copy the first, exactly the same. You copy the last, exactly the same. And you will replace 17 using 18 and 1. And be careful with the sign, minus 18, okay, plus 1k. If you combine 18 and 1 is 17, and we come back at the beginning, but no, I don't want to come back at the beginning. I want to apply grouping now. Here.
Professor,
Go ahead.
I got a doctor's appointment I have to go to. I may miss out on some class.
Okay, I understand. Entonces now my recommendation is you watching the video after, okay?
Yeah.
Super.
Right.
I mean, you are a good student. Okay, now entonces grouping is where the greatest common factor and the red couple is 6k. We have k minus 3. What is the greatest common factor in the blue couple? No greatest common factor, and no greatest common factor mean 1. K minus 3. I am happy because in that moment, this expression and this expression is the same. Therefore, you factor out k minus 3 and 6k plus 1. And don't forget that this is equation, so I put equal 0 here. One equation is x minus 3 equals 0. This does mean that k is 3 and 6k plus 1 equals to 0. Does mean that k is equal. Let me see. You move 1 to the right hand side. Wait, too fast. I am doing no good. Okay, look, is 6k equal negative 1 divided by 6. Therefore, k is equal negative 1 over 6. Okay. Negative 1 over 6 and positive 3 is the solution for the 51 quadratic equation. 51, negative 6, negative 1 over 6 and 3, no? SA again. SA. Look. Any question, guy? I am doing too fast or I am doing well? Okay. The thing that we're studying now is one application, not the unique. We saw more. Application of the factorization in algebra. One fantastic application is solving the quadratic equation by factoring. 52 is easier. Wow, super easy. 52 is 7m squared minus 3m equal to 0. It's a binomial. Pero no square. No. Es, remember the tragedy for the factorization. Is there a common factor? Of course. The great common factor in this couple is m. Factorization m, and we have 7m minus 3. That's it. Now, how many factors we have? We have 2. M, okay, is equal to 0, and 7m minus 3 equal to 0. So this is already isolated. M is 0. One solution is 0. Okay, good. And the second, no. The second is 7m equal to 3 divided by 7. Both sides. M alone is 3 over 7. With two solutions, 0 and 3 over 7 positive. Like the option A again. Like the option A again. 3 over 7 and 0. Everyone follow me? Yeah. Okay. So let's see now. Okay, Santana is a yes. And David. Let's see another application of the factorization. That is the reason that factorization is extremely important in algebra. We have now fractions. We have rational expression. Rational expression is, by definition, rational expressions is a polynomial divided by another polynomial. Suppose that we have in the 53 problem, we have m squared minus 4 divided by m squared plus 4m plus 4. It's given, no? But the question? The question says simplify if it's possible. What should I do? Well, you factorization the top part and the bottom part separately. We focus, see, in that part. Entonces dice, wow. Es a binomial, professor. It's the differences of the square. Okay, I'm using the famous formula. The factorization is then mm to 2. Where I come from m and 2? Square root m squared is m, square root 4 is 2. And plus and minus. Done. I did the factorization of the top part. Now let's do the factorization of the bottom part. The bottom part is, it's a trinomial. But what kind of trinomial? Es regular. Si es regular, entonces Caesar. Es mm, and the combination is 2 and 2 again, no? Because 2 times 2 is 4, and 2 plus 2 is 4. It's like a perfect square, and the sign is positive. Okay, now I can see, I discover this factor is x plus 2, and this factor is x plus 2 cancel out, and we can delete in our expression. So my final answer is minus 2. When you have one factor, not necessarily put the parentheses. You put the parentheses, okay, but no, n plus 2. And this is my final answer. So now, this is no equation. That problem is no equation. It's expression, manipulation, simplify expression. So you manipulate until you get the solution is, in this case, you see, is this, D. Okay, do you understand the idea for the simplify rational expression? We have fractions. Rational is equivalent, synonym to say fractions. You factorization totally, factor completed the top part, factor completed the bottom part, and the factor, they are twin brothers, you delete. Same, because any factor divided by, what is the reason I can delete? A reason I can delete because you have any factor divided by the same factor, get the same, and 1. And one shortcut is delete. And delete disappear because 1 is invisible. Okay. This is the theoretical part behind this. Okay, let's move on to the 54. 54 problem is similar, simplify. Simplify the expression is 3x plus 2 divided by 15x squared plus 22 x plus a. Wow, what the hell? Okay. In the top part, we cannot do anything because this binomial is prime. We cannot break it down. However, this is complicated. I suppose I did before similar. Now let me see. Yeah, I suppose. Yeah, look, it's very similar to the problem 50 I did before. Es obvio. Bueno, actually, I discovered que es special, right? Because 15. And when you multiply 15 and a, I did before, the answer is the 15 times a is 120. No good for grouping. No. So let's try an error. 15x, 1x is the combination for this. 5x, 3x is the combination for this. We have 2 combinations. In that case, it's a and 1. and 2 and 4. Or 4 and 2. I like to put it bigger first. So I try this combination. This combination is you copy in two different possibilities. Okay, we have case 5x, 3x, 5x, 3x. The first part I did exactly the same. The difference is now 4, 2, 2, 4. I switch it that. And you multiply 10, x, 12. Okay, what's the combination of the word? 22. And this combination, no. Okay, I did before. That is a reason I don't want to. Okay, so now the factorization is obvious que es plus plus. The factorization is 5x plus 4, 3x plus 2. Nice. I like that because I discovered that the factor 3x plus 2 is common and I cancel out. Cancel out, cancel out. Okay, this is what is my final expression. Well, on the top, and the top we have nothing, and nothing is 1. The bottom we have only alive 5x plus 4. Okay, entonces the option C, look at that. Option C. The new thing that bring me this example was, okay, the factorization actually we did before. Is when the in the top or in the bottom, no, in the top specifically, we have nothing because cancel out. You put an extra 1 here. Different situation happen when it's in the bottom. When it's in the bottom and cancel out, and the answer is 1. So say it's not necessary to write. Not necessary to write. Okay, let's do in the number 55. Actually, the thing that we are doing now is manipulate and simplify only one expression. You see in the next example, 56, 57, and so on. Wow, we have 2 expressions. But it's the same procedure. So it's a squared minus 9 divided by a minus 3. Oh, this is a difference of a square and the top. Open two parentheses is AA33 plus and minus. And this is a minus 3. Wow, so this is look in this example, look. This and this cancel out, but stay alive only a plus 3 in the top, and the bottom is 1 because we have nothing. When this situation happens, when the bottom is 1, you can omit that part. When it's in the top, no, like the previous example. When it's in the bottom 1, you can omit, and the final answer is a plus 3. Got it? Okay, let's practice. Let's practice. Guys, I am concerning. I am doing too fast. You understand? You follow me? Angelica, answer me, please. Angelica. Christopher Pinoza. Okay, good. Okay. Thank you. Kevin. Alejandro. Okay, no problem. I suppose you see before in your life. Okay, the objective of this subject is basically reinforce this concept because we are using algebra. Okay, let me try 56, que es no big deal, pero es long. It's very, very long. 56 is, let me try to copy. K squared plus 10k plus 21 divided by k squared plus 13k plus 42 time. It's multiplication. We have one fraction, one rational expression, and we have another case k squared plus 6k divided by k squared minus 4k minus 21. Well, what should I do? Well, factorization one by one. Factorization. You determine. Classification is a very extremely important. What kind of expression we are doing? Trinomial, binomial. Okay, the trinomial at the top and the first fraction, we can do here in the top part. KK, the combination that open the door is 7 and 3. Because 7 times 3 is 21, 7 plus 3 is 10 plus. I did the factorization. Now, let's do in the factorization this guy. Again, it's regular. And regular is easy. No complication, no multiplication like that. No. Open the parentheses, put the name of the variable, find the combination, and open the door. Okay, suppose que 7 and 6. Because 7 times 6 is 42, and addition is 13. Plus. Every sign is positive. It's obvious. Let's do this. It's a KK. This is similar to this 7 and 3. But this is opposite. It's different sign. Negative. 7 and negative. 3 is positive. And the last one is super easy because it's binomial. And the only thing, no different of a square, no, because 6 is no perfect square number. It's the only possibility you could do here is a common fact, GCF. The GCF is k. And we have k plus 6. And that's it. Now it's the crucial moment in which you delete the common fact. And you can see, wow. In the top, you consider like a, remember, this is the top, completely top. It's separate here, but by period, the multiplication. But no, it's no. You consider this is the entire top and entire bottom. Entonces es x plus 7, and x plus 7 is cancelled. K plus 3 and k plus 3 is cancelled out. K plus 6 and k plus 6 is cancelled out. And who stay alive? Stay alive only in the top k and the bottom k minus 7. Boom. Final answer. Option C in this case. Any question? Application for the factorization. Simplify complicated expression. You factor it one by one. The factor is the same. You delete. Okay? And we stay alive. The factor is not repeated. Of course, you cancel out. It's important to understand this. You have one expression. You have one expression. Any division is the only possibility to cancel out. So you have any, the same twin brother, but multiplication, no cancel out. Only when it's division, right? $57. Oof. 57. 57 say k squared plus 14k plus 45 divided by k squared plus 16k plus 63 times k squared plus 7k and k squared plus 10k plus 25. Oh, it's easy. It's similar. Let's do it. Trinomial regular. KK. The combination that open the door is 9 and 5. Because 9 times 5 is 45, and 9 plus 5 is 14. Plus. Every sign is a plus, it's obviously plus. The second, again, regular. KK. And 9 and 7. 9 times 7 is 63, 9 plus 7 is 16, plus. Okay, this is also. By the way, this is perfect square, but no, I consider like a regular. Okay, 5. Because 5 times 5 is 25, and 5 plus 5 is 10. It's perfect square because it's a repetition. It's the same number plus it's 5. In this case, no, because it's 9 and 7 or 9 and 5. In this case, perfect square. But okay, I can consider it like that. And finally, this is k greater than factor k plus m. Ready to simplification. K plus 9, k plus 5. Doesn't matter what you delete, it's the same. K plus 7. We stay k in the top over k plus 5. I'm going to be checking. Yes, option B. Any question, guys? 457. Let me see. I want to delete everything. This is page number 5 in our handout. Let me see what is it. I suppose it's the last page, no? No, not the last, of course. 33. Okay, what page? It's this page. This is the last page. No, we have 2 more. Okay, this is the page. Okay, boom. Okay, good. 58. 58, say. X minus a divided by x plus 3 squared. Let's repeat it. You know, this is equivalent to say x plus 3 times x plus 3, no? Well, no, it's okay. Leave it like that. Multiplication time period. Period is the arithmetic operation. Period is multiplication. We have one expression that is not already factorable. So I take advantage. This is factorable. But this is x squared minus 5x plus 24 divided by x minus a squared. Okay. I don't do anything here. Oh, the only guy pay attention is in this. It's not already factorable. And the combination, the key que open the door is 8 and 3, because 8 times 3 is 24, 8 minus 3 is 5. And wait. And minus, oh sorry, minus. Aha, thank you, Kevin. See, S plus doesn't work. Thank you, Kevin. And minus. Minus here indicate different sign, negative 8 and positive 3. Good. Okay, so we analyze what factors cancel, what factors stay. Well, x minus 3, x plus 3, sorry, cancel out with the only one. And the symbolic way is this, because you have 2 here, and you know, x minus a and x minus a together is x minus a squared, cancel out with this. So this and this cancel out with the completely this. Wow. Entonces, what is the final answer? I am lost. In the top, nothing. 1. In the bottom, x plus 3. Only that. Yeah. And the option B. Okay, super. I understand now. Okay. Now 59 is different. Why is different? Because it's division. So the problem that we're doing so far. So we study simplification of the fractions. Number 1, using only 1. Number 2, using 2, but of the connection. The arithmetic operation between is multiplication. Now I change a little bit when the arithmetic operation is division. Entonces, pero es similar. Look, let me show you. 59. 59 is, okay, it's negative 4 plus 2x divided by 4 division 8 minus 4x over 8. Well. So I copy, when the division, I copy the first fraction exactly the same. I don't touch. And you convert now more division problem to multiplication problem. How? Flip it, the second fraction. Now I continue doing exactly the same of the problem we're doing before. Okay? Now you factorization this guy. Let me try. In this case, binomial. Okay, binomial, this guy. I focus on this guy. Binomial is greater common factor is 2 or negative 2, I suppose. I don't know. 2, negative 2. So I factor out negative 2. So we have positive 2 plus or minus x, something like that. 4, well, 4 is number. A is a number. And here, the great common factor is 4. And we have 2 minus 2, minus x. Okay, I like that. I like that because 2 minus x, it cancels out 2 minus x. Because in the top, we have, you can do it in a different way, but you multiply it. This is 16. Look, this is minus 16. Where come from 16? Negative 2 times 8. And 4 times 4 is 16. Wow. Entonces the answer is negative 1. Yeah, the answer is negative 1. Negative 1 is the answer. No algebra, is just numerical value. Negative 1. Guys, there are many ways to do this. But well, I explain only one way. The way in this moment I consider better. There are many ways. I know the people. Okay, but it's okay. Let's do it another way. 60 now. 60 now. 60 now. 60 now. 60 now. 60 is x squared minus 16 over 25 x squared minus 9 division x minus 4 over 3 minus 5x. Well, this example brings me a new situation. Well, no, okay. The situation of the division that we covered before, we flip it. You copy that. Exactly the same. I don't touch. And you convert to multiplication when you flip it. Okay. Now I pay attention now. Our problem like a multiplication, exactly the same we're doing before. With the factorization, this guy, I can see, wow, a binomial is different of a square. It's xx 4 because square root 16 4 plus or minus. It's easy. The similar is the bottom part. The bottom part is different of a square, again, binomial. And you know, one clue is different of a square is one of subtraction, of course. But 25 and 9 are perfect square numbers. 5x 33 plus or minus. And that's it. And that's it because this expression is prime and this expression is prime. We can do anything. Okay, now this is a crucial moment to simplification. Remember, the twin brother, we can delete x minus 4 and x minus 4. However, we have one family que no necesarily is twin brother, que is, look, let me show you, let me explain in detail that part. We focus on this, 3 minus 5x divided by 5x Minus 3. Do you see it look like similar, right? Look like similar, but they have opposite, totally opposite sign. In the top, 3 is positive. In the bottom, 3 is negative. In the top, 5x is negative. And the bottom, 5x is positive. When this situation happens, they are family, but not twin. The answer is no 1. No, 1 is when the twin brother is negative 1. Okay, opposite sign, totally opposite sign is negative 1. So actually, I highly recommend that you delete similar to the twin brother, but don't forget that they are not twin brothers. The answer is negative 1. Under, so you delete under the condition that they are family, but not twins. So the answer is no 1, is negative 1, because it's totally opposite sign. Okay. So what is my final answer? I am lost. Stay alive, x plus 4, 5x plus 3, and don't forget also copy negative 1. Okay, my recommendation is copy in the front like that. Negative, like a fraction, x plus 4 over 5x plus 3. Something like that. Okay, let me try, let me see. Let me check it. This is number 60. 60. Okay. FB. Any question, guys? Do you understand this? Okay, family, negative 1. I consider a family. O sea, no any family. Suppose x, suppose this binomial, x minus 2 divided by 2 minus x. The answer is negative 1. Suppose x minus 2 divided by x minus 2. Oh, twin brother, the answer is 1. Suppose, let me see, x minus 2, and we have minus 2 minus x. No family, no twins, because we have one extra negative here. So it's completely opposite sign. So see 2 is negative in the top and it's positive in the bottom. See x is positive in the top and x is negative, to say negative 1. This is nothing. I don't know. I have no idea what is that. No family. Twins and family. Okay. Do you understand the new idea for the, okay, and in the review for the test, I promise I practice more family and twins. Okay. Let's move on to the one important but a little bit complicated part. Okay, is addition and subtraction. Addition and subtraction to fraction or to rational expression, algebra, is a little bit, so I need to introduce to the one thing that you know very well, que is the least common denominator. Least common denominator. But the student confused. Okay, actually, this is a least common multiple. This equivalency, least common multiple. But specifically multiple of what? Of the number in the denominator. Let me explain the idea for the least common multiple and to compare with the least, the greatest common factor. Because you are familiar with the greatest common factor, GCF. And you confusing with the least common denominator. It's completely different. Let me put one very illustrative example, numerical example, to understand much better. After we use algebra, it's algebra expression. Suppose 9 and 15. Okay, I need to find, well, 9 is 3, 3, and 15 is 3, 5. Suppose they want to find greater common factor between 9 and 15. And well, we are familiar. Greater common factor is 9, because the rules say, can you take the common, but you take, no, S3, sorry, S3. 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 You take the common. The common is, look, 3 is common. And that's it. When you take this, disappear, you factor out. And this stay 1, 3 here, pero 15 have no more 3, entonces no common. However, the least common denominator or least common multiple, okay, the same idea, is different. Least common denominator, and between 9 and 15 and 45. Wow, professor, where come from 45? Well, remember the word multiply. Multiply indicate multiplication. Multiplication. So, for example, I try to understand what is the key behind that, and after I explain the shortcut to find easy. Suppose you have 9 and 15, okay, our example. And you multiply, multiple indicate multiplication. Multiplication by 1, multiplication by 2, multiplication by 3, and so by 4. When you multiplication by 2, this is 18, and this is 30. When you multiplication by 3, this is 27, and this is 45, no? Yeah. When you multiplication by 4, it's 36. And this is 60, I guess so. Yeah, 60. And when you multiplication by 5, it's 45 and 75. And you keep going, multiplication, and we have a collection of the number. However, I discover, look at that, 45 is the least common multiple. Because I promise, if you continue forever, we discover more common multiple, but the least common multiple is 45. This is the idea behind least common multiple or least common denominator. So, okay, professor, okay, I understand, but this is too long process. I know. No, nobody do it that way. Okay, the rules say. Okay, when you're doing the factorization, okay, I want to repeat again. Look. S9, S33, and 15, S35. The rules say you have to take every factor, not like a GCF, que you take the repetition, every factor. But the factor gets repeated you take the majority of this. Majority of the. So, according to the rule, you take every factor. You take 3 and 5. It's the only factor we have in our problem. The challenge is the factor gets repeated. 3 is repeated. 5 no. You take the majority. The majority is here. 2, 3. This 3 no, and this 5. Because you have to take every factor. No omission, any factor. See, some factor is repeated, so you take when you have more amount. And delete this, the less amount. And you multiply now 3 times 3 is 9, and 9 times 5 45, and you get exactly the same answer. Super easy. 45 comes from 3 times 3 times 5. This 3, and this 5. It's the least common denominator idea. Let's move on. Do you understand or no? Wait. Entonces, okay. I understand, Professor. But we are need to using algebra. So algebra expression. This is numeric, arithmetic. So it's the same idea. For example, you have one expression que es x squared, and another expression que es x cubed. But let me complicate a little bit. X squared y and x cubed y squared and y. Yeah, I need to find the least common. Well, let's do them both for practice. Let's do them both. So no number, only variable now. And for practice, GCF of x squared y squared, no comma. Comma x cubed y. And least common denominator or least common multiple of the same. Y no comma. Comma x cubed y. No comma. Y. Well, in this case, it's obvious. Can you take always the smaller exponent? And the smaller exponent is x squared and y. Okay, this is the greater common factor. And in this case, completely opposite. Because you take majority. You take the bigger exponent, x cubed, y squared. Do you understand? And suppose in one specific factorization, we have this is monomial expression. This is look like easy. However, you have, for example, different factor. You have x minus 5. You have, for example, x minus 5 squared, x minus 3, and we have a that's it. 2. No complicated with 3. Only 2. And you find, for example, here again greater common factor of x minus 5, comma x minus 5 squared, x minus 3, and you find the least common denominator in between x minus 5 and x minus 5 squared x minus 3. According to the idea greater common factor, you take the common factor, the factor que both expressions share. Obviously, is this and this. This and this. X minus 5, I can see, get repeated. And you take the smaller. The answer is x minus 5. Greater common GCF, greater common factor is x minus 5. You take a smaller exponent. Least common denominator? No. You take every factor. So in my final answer, participate x minus 5 and x minus 3. And you take the greater exponent. So it's x minus 5 squared times x minus 3. Okay? This is a big picture about the differences. And what is the reason that we study least common denominator? Well, because we are using an addition and subtraction. In addition and subtraction, is mandatory using least common denominator. Let's do one elementary example completely. Suppose que you adding 2/3 numérica, to donde estamos after algebra, plus 1/6 plus 5/12. By hand, well, I put in a calculator, that's it, no? By hand. It's important by hand because in the algebra expression that we have variable, we cannot put variable in the calculator, no? Or at least in the regular calculator. That's the first step. Number 1 is find least common denominator. Least common denominator between 3, 6, and 12. O sea, least common denominator between 3, 6, and 12. You can use intuition. Intuition. According to my intuition, is 12, no? Remember, least common denominator is multiple. Pero no, it's okay, it's okay. So you have no intuition, no problem. We take 3, 6, and 12. Break it down and prime factorization. 3 is prime, stay the same. This is 3. This is 2, 6. This is 2, 3. Remember the idea is you take every factor. The factor involved in my problem is 2 and 3. And this answer, mandatory you put 2 and 3. The problem is how many 2, how many 3. When it's obvious that the 2, the majority is this. Look. Therefore, these 2, delete. You take 2, 2. 2 2. Time and 3. On 3 you have 1, 1, 1. Use the either one. Suppose this. Or this, doesn't matter. So you delete this and you delete that. That's 3. And we get the answer. That's 12. Exactly we expect by intuition. No? Multiple, common, multiple. When you multiply 3 times 4 is 12, 6 times 2 is 12, 12 times 1 is 12. Then you copy now, you copy now 2 new fractions. Using the least common denominator, that's 12. And you try to find 12, not 13, carajo. And you try to find equivalent fraction, question mark, equivalent to the number 1, number 2, and number 3. Well, number 3 is super easy because it's the same. It's the same. Entonces, si es the same, I erase this question mark and replace immediately for 5. Because 5 over 12 is 5 over 12. And the rest, no. So what is the procedure? Let me explain in detail the procedure. I want to erase that part now. Okay. There are many ways. You divide. Divide what? Divide by the least common denominator, is 12. Divided by the denominator. So LCD gets 12 in our case, divided by denominator I call, for example, denominator 1, because it's 1, 2, 3. Okay, 3 is 4. And this 4 multiplied by the corresponding numerator 1 in the same fraction. Que in our case 2. Entonces 4 times 2 is 8. Bam. I replace the question mark for 8. Okay, guys, this is super easy. Another way to see the problem is, look, 2 over 3 is equal, I have no idea, over 12. You apply cross multiplication here. It's 24, 2 times 12, 3x. 24, 3x. Divided by 3, it's obvious that x is 8. Okay? Anyway, either way. Division, this divided by this. 12 divided by 6 is 2 times 1 is 2. Is 12 divided by 6 is 2. And 2 times the corresponding numerator, in this case 1, is 2. Okay, nice. So now is 2. I put it here. I replace this question mark by 2. Now you adding. It's super easy. When the denominator is the same, you copy. And you add in the top part. It's 15. Okay, 8 plus 2 is 10 plus 5 is 15. And leave it like that, no? No, why not? Because now I find the GCF. The GCF. Yeah, GCF, que the common factor. So in my mind, 15. 15 is 5 and 3. I break it down this. 12 is 4 and 3. Yeah, I discovered that the GCF in between this number. GCF, not this common denominator. GCF between 15 and 12 is 3. And the GCA helped me exactly the same we studied before to simplify the fraction. 5/4. Done. Do you understand? Well, you remember this. This is arithmetic, basic arithmetic. But in algebra, we are doing exactly the same. Exactly the same. Exactly the same. No differences. Let me come back again to the handout and try to do at least the first. The first case number 40, no, 60. 61. 61. 61 is 5 over x plus 5 plus 3 over x. Okay. We have now different denominator. Therefore, I need to condense in this and only one least common denominator. Least common denominator. And the rule, remember, is when you have, well, you need to take every factor. And only way that you repeated something, you take majority. But in this case, not repeated. You take x plus 5 and x together. This is my least common denominator. One good habit, in my opinion, is put the long line instead of separating two different fractions. And you copy here the LCD. Okay, so in order to determine the top part, is equivalent to this. You divide this divided by this. You divide mentally. You divide x plus 5 divided by denominator 1, que es x plus 5. Stay alive only x times 5, que es the corresponding numerator, es 5x. Plus. This divided by this. Very, very similar. LCD. Now divided by denominator 2, que es x. Cancel out the x. Stay alive x plus 5 times 3. 3 times x plus 5. That's it, no. No. I need to continue. I remove the parentheses, at least in the top. Try. This stays the same temporal so far. Maybe no. Maybe I need to remove, but no. You copy 5x and you copy 3x. Distribute the property. Plus 15. And now we combine ax plus 15 divided by x plus 5. Guys, extremely important. We cannot illegal simplification this and this. No, big mistake. Okay, you can simplification only when there's a product. So as you have, for example, I don't know, x plus 3, x plus 5, divided, it's time here, no plus. X plus 3, oh yeah, you can simplify this and this. But when it's plus or minus, no, this is stupid. It's stupid, look at that. It's like, for example, 64 divided by 16. You can delete this 6, no. Why no? Because 64 is 60 plus 4. And 16 is 10 plus 6. And this 60 and this 6 have not the same value. It's totally illegal, cancel out this. Because it's 10 times this. O sea, no. O sea, what is my final answer? I suppose que this is my final answer. Leave like that. Or no, or remove the parenthesis in the denominator, maybe. Now let me see. Ax plus 15, x times. Oh yeah, es the option A. Yes. Es the option A. Do you understand the difference between addition or subtraction? O sea, new complication. Well, not new. But, you know, when you're adding or subtracting, you need to create artificially maybe the same denominator. See, our original problem have the same denominator that you need to condensing using the least common denominator. Let's practice least common denominator, least common denominator. So two step, least common denominator is the first step, and the second denominator, the second step is express both fraction or three fraction, the fraction that we have, equivalent using the same denominator. Suppose 62 is easy also. Is 4 over r plus 7 over r minus 2. The least common denominator obviously is similar to the previous, is r times r minus 2. No repetition, take both. When you put the top part as this divided by this is r minus 2 times 4 plus this divided by this is r 7r. Do you follow me? Now what should I do? Well, distribute the property here. Is 4r minus 8 plus 7r divided by r times r minus 2. It's 11. 11r minus 8 over r minus 2. And don't do any more. 11r minus 8 r minus 2 at d. We can know simplification. Remember, when it's addition or subtraction, no, when the plus or minus, we never simplification. Okay. This was 62. Guy, I need feedback. Do you follow me? It's okay? Do you remember? David left. Wow, David. Guy, opinions? Are you sleeping? Angelica. You follow me or not? David, come back, join. What's going on? You have problem with internet? Okay, following. Espinosa, do you follow me or no? Espinosa, sleeping, Espinosa, following. Okay. Let's continue practice. 63. 63 is, well, no similar. Have a new idea. Okay, 63. 63 is 7 over parenthesis x plus 6 squared plus 2 over x plus 6. Okay, number one, find the LCD. LCD, remember, have a participation, any factor in my problem. However, when they are repetition, you take the majority of them. Majority is x plus 6 squared. Okay, this one. It's a coincidence with this. We have 7 plus 2 times x plus 6, something like that. When you divide this divided by this, stay only one x plus 6 times 2 is 2 times this. Now you distribute here. Let's say 7 plus 2x plus 12 over x plus 6 squared. Well, let's say we have 2x plus 19, huh? Yeah, 19. 7 and 12 together, 19. X plus 6 squared. We have GCF here, no? Oh, no GCF, 19 is prime, 2 is prime. Leave it like that. The answer is this. Okay. Wow, time fly. Okay, guys, yeah, I know. Okay, 63, 64. We continue Wednesday. Okay. Do you see in this email I sent to you? Okay, let me stop sharing. In this email I sent to you